I'm so delighted to be here to talk. I'm going to have a very nerdy talk. I hope you enjoy it. But I really enjoyed the first workshop. And for me, part of the delight of coming here was also to take the other workshops for this. So today I'm going to talk a lot about robotics and design, and specifically where I see the role of design growing into the future. And a lot of that has to do with animacy and agency in robotics. So the agenda for today, just a little bit of a breakdown. I'll talk a little bit about my journey from the world of design into robotics and some of the pitfalls along the way, some of the gaps in my education that I had to take a long time to build bridges for. I want to share some other creative practitioners who are really working at the fringes of defining these new roles in relationships with machines that have the ability to move and manipulate the world. And then I thought I would end with some references and resources. So a couple books and a couple tools that there's something that maybe you might want to bring back into your classrooms. And then a short exercise at the very end. And so we're going to talk a lot about robots today. My background in particular, I'm trained as an architect, but by practice, I'm a roboticist. And what that really looks like is starting in a design school, in an architecture school, and learning how to talk to machines. And that was a skill that there was no actual curriculum for. Actually, I joined a master's program in Carnegie Mellon that had zero curriculum. It just gave you like a hall pass to any other department in the university. And you just had to do a thesis for it. And that led to a PhD in more advanced research, which led to a role at NVIDIA. So my original background was in making computer-aided design and computer-aided manufacturing tools. So coming from architecture, where I had to use a tool made by Autodesk, made for hundreds of thousands of practitioners to design a building, I found myself wanting to do things with these machines that were not supported by the general use case of this mass market tool. And so I developed a skill of creating things in simulation. Making these little computer-aided modeling tools that let me do one thing for one person rather than thinking about this huge scale, kind of the opposite of what they teach you about software design, that should be generalizable and that it should be scalable. I was building a thing for me. And this was the first thing that I ever, like big girl pants programmed by myself. I had a horrible time learning how to program. I got to it very late in life. I was maybe 24, 26, but I was taking classes with 17-year-olds who were programming before they could read. So it was humiliating, humbling, and good medicine to take. And so this is one of the first things I made. It's a 3D squid that you can drag around, and it has its own sort of sense of being. It keeps itself inflated, and it doesn't kind of intersect with itself. It has a physical properties built into it. And then I decided that I want to take this thing and I want to use it to co-create some 3D designs with. So this is a 3D scan of my own body, and you're seeing my hand dragging this thing around through space. And it is deciding how it moves around and how it repels off of the scan. And this was the first tool that I built that let me kind of immediately connect this idea of sketching with code with getting something out into the physical world. So this thing that I could create and be very intuitive and have zero friction between a gesture and an output was my first thing of talking to a machine. This was embedding the properties and knowledge of a 3D printer into a piece of digital software. And that was kind of the start from my journey from architecture, very classic architecture training, to talking to machines. That project led to some follow-up work and some invitations into the world of HCI. I was fortunate enough to get an opportunity to work with Autodesk Research in their user interface research group. And we took this idea of designing something around my body, and why not just design it on your body? So here is a bit of the back end. Basically, you see the projection of the 3D model on your body. There's a sensor detecting how you're interacting with it, whether you're poking, pinching, prodding, and then a CAD backend that you don't ever need to see And once you close your hand, it exports to a machine doing a 3D printing bureau way far away in New York, and 2 weeks later you get your print back. And so this for me is one of my tricks that sort of developed over time was to design for animacy, design for agency, to build tools that extend beyond my imagination. So I see these systems that I make as a bit of a prosthetic. I think of myself and maybe a lot of us as deeply flawed and limited in our creativity and in our imagination. But we can build tools that act as a prosthetic to expand that. And at the same time, I was also, like, one of the amazing things about Carnegie Mellon University and being in Pittsburgh is that it's the robotics capital of North America. And there are just robots sitting there lonely, not doing anything in the third sub-basement of our room in just about every building in the university. And so the School of Architecture, where I studied, had this machine that no one really knew how to use. And the beauty of that, too, is when you know as much as the instructor, you also don't know what you're not supposed to do. Which there's like 2 rules with industrial robotics. It's don't touch it and don't make it interactive. And so I made a back massaging robot because it was very frustrating to program. So I decided to program a routine that let it, when I leaned back into it, it would massage harder. When I leaned away, it would back off a little bit. And my bias towards interaction really coming from the world of software, like for working with a 3D printer, it's a robot with 3 motors moving in 3 axes. And industrial robot is just another 3 motors, so how hard could it actually be? So a lot of my work really brings tools of automation and misuses them for the purpose of interaction. And it's been, for me, it's been a really amazing way to begin to pull at what the future of this technology could hold. So I think of robots as giving us technological telekinesis, like this ability to move matter with your mind. And the amazing thing of where we are right now is that we're seeing this connection between science fiction and fantasy and actual reality. So this is one of my favorite movies growing up, Matilda, where she learns she can unlock her telekinetic powers to make herself breakfast. And you can also like press a button and have your breakfast delivered to you by a robot. This is a really famous scene from The Matrix where the protagonist learns he can bend things with his mind. And so this is science fiction. And the reality is this robotic spoon that accounts for your hand tremors. So if you're older or if you have a debilitating hand tremor, you can actually live independently and feed yourself. And same thing with Mickey here, right? This is now the role of magic and fantasy. We have this will and yearning to not have to mop and vacuum. And this is kind of like the amazing robotic reality that we have today. And this image in particular is something that really fascinates me because I see today as so much more interesting than the stories that we have of robots in our life. And so, for example, like these are maybe when you close your eyes and in your mind's eye, you think of what is a robot. Probably these pop culture icons come to mind at some point from Star Wars or the Jetsons. Like this is the future that we're asking for. But that fantasy is so less interesting than like a duck being chased by a cat in a shark costume on a robot, right? And so what I see our role as designers and as artists is to really start to build out these new narratives because the stories of our future are really from our far past at this point. And that's the work that I try to do.
I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine.
So I've built a bit of a career properly misusing machines and resisting really being in one particular discipline. This project in particular was taking cameras used in the film industry that could see the world but not move, and making some digital duct tape that piped that information to a robot that could move but not see in the world. It was something that was quite obvious to me, but unlocked a lot of potential that really took my career in a different direction than I was anticipating. And so for me, as the programmer of this system, like, I knew the effect that I was having on this machine. What I didn't realize was the effect that it was having on me. And just by standing in front of this big beast of a machine, I felt less and less like a designer and more like a lion tamer, standing in front of this big giant beast that might crush me, but hopefully doesn't. And that was something that I wasn't really anticipating as I was developing the system. This was actually for a completely different project that never happened. Because what folks were so interested in this was not really what the robot was doing, but my relationship with it and what our bodies were talking to each other about in space. So for the purpose of this workshop, I'd like to expand our definition of what a robot is a little bit. So these are some of the common things. When we think of robot, we might think of a humanoid robot, something that looks like us. We might think of it as intelligent. We might think of it as a bit intimidating and potentially replacing us. But I'd like us to think about a robot as anything with mechanical mind and mechanical muscles. And the way that artificial intelligence is AI in robotics is a way of making these mechanical minds more adaptable, right? So you don't have to explicitly program it to do everything. It can start to improv and understand its context a little bit more. Machine learning is kind of a subset of that. Those are the actual algorithms that help a machine see signal from noise. And it's a very effective way that has allowed us to use a lot cheaper sensors, a lot cheaper software to gain a lot of performance out of these machines. And so AI in robotics, artificial intelligence really helps a robotic brain generalize and abstract information away. So some things that I was good at, and I think John talked about a lot of this, it's really, really good at machine vision, at object detection, facial features, pose detection, localization. It's all software. It's really good in simulation, and this is something that is rapidly improving. So again, taking noisy input and getting really, really good quality information out of that. And also being able to train a robot in simulation and transfer it onto a physical thing is something that is currently an active area of research that is rapidly commercializing. When you have this broader definition of what a robot is, I think we actually have them all around us, from the industrial robots that I work with a lot, but to self-driving vehicles, which are out in the wild now in certain parts of the world, to delivery drones. Hospitals will often have robots that deliver towels and goods, maybe from a central repository to individual rooms, to robotic toys, to even 3D printers are a dumb robot, but still a really valuable robot. What I love most about industrial robots is that it's this thing that has superhuman strength, superhuman speed, superhuman precision, superhuman endurance, and it is just being locked away in a factory doing boring, repetitive tasks 24/7 over and over again. And one of the most interesting things is that the birth of robotics in engineering and the birth of robotics for like creative uses really share the same point. This is some of the first systems developed mostly by the US military, but for the first computer-controlled machine, first robot arm on a factory line. And around the same time, you had kind of the same engineers exploring robots that had personality, robots that had a sense of life, robots that were companions with us. And so the work that I do, I sort of see that we kind of got stuck on this timeline where robots are used for efficiency and optimization and repetition. And I want to live in a world where robots are curious and kind and alive. And so that's the type of future that I try to make with my machines. So this is Mimus. Mimus is an industrial robot that lived on a factory assembly line in Birmingham in the UK. And the Design Museum in London was kind enough to let me offer her a holiday for 6 months to come and live in the museum and just be with the museum goers and to just live and exist. So you see here something quite different is that Mimus has nothing on her face. All she has to do is exist. It's the first robot in history who her job is to do nothing and to really just enjoy her experience with the people around her. And what I like about this is that working with cultural institutions allows you to bring these really esoteric concepts and highly technical things out of laboratories to have lots of touch points with society so that they can start to be aware of the capabilities, the limitations, and the exciting opportunities for this new technology. So for those kids that I got to work with at that workshop, this was something that now they expect that their robot should be attentive and curious and kind to them. And that's a nice baseline to start with that expectation of our technology. To do this, it was something that we had to kind of re-engineer a lot of off-the-shelf software and off-the-shelf hardware to do. So my friend Kevin and I built this system where we tore apart 10 Microsoft Kinects. These are $35 game sensors that we then put in the ceiling. And I developed a crowd tracking piece of software that allowed Mimus to see all the visitors around her. And so here they are. So they have a bird's eye view. They can sort of see where the head is, where the arms are, how quickly they're moving around, how long they've been there. And that allows Mimus to take cold, hard numbers and begin to infer some relationship details. So for example, if you've been there a long time and your proximity to Mimus is getting closer and closer over time, that perhaps you've built up a rapport, perhaps you've built up trust, and that Mimus should go visit you before everyone else. Or if you're standing still for a long time and you're not really being active, Mimus should have every right to get bored and go check out someone else. So here she is. This is a really amazing opportunity. The Design Museum just went over a huge renovation. This was the inaugural exhibit for Fear and Love. And so the curators asked me to come up with something that could talk to the duality of our kind of, our joy and our deep esoteric fear of this technology replacing us. And for my machines, I really don't try to push one narrative versus the other. I try to leave space for people to begin to develop their own opinions on how they want this technology to go. So Mimus was about one big robot interacting with a crowd of people. And the World Economic Forum invited me to do another installation where ABB was a sponsor, so I could ask for more robots. And the idea was to now be surrounded by these machines. And this is kind of more to the point of where our future is heading, where now the machines can outnumber us in certain contexts. So these robots are on an assembly line on a bed of light. And what's interesting about them is that they all share one brain. It's one of these affordances that we see these machines as individual beings, but we don't quite understand that their bodies and their sensors and their brain are completely decoupled, and they can be mixed and matched in many ways. And so these robots here, they're a bit nearsighted. The sensors are down in the base, so they're looking up at you. They have a worm's eye view. So you have to get very, very close, and you sort of see all the rest of them at the periphery, getting a little bit interested in you. And so for this, a lot of the work that I do uses open source creative coding toolkits. This is developed in open frameworks. It's not generally used for robotics, but I contribute back a lot of these tools to that environment because that's how I learned to program, and I want more people with a diverse background to be able to participate. And this project for me was really interesting. It was the first time I was doing work for policymakers. So these 10 robots were in a room with some of the most important people in their country. And so we could do a little bit of magic to help undermine that a little bit. So a lot of it is if you know, a natural thing when you come up to a robot is to conduct it. And so if ever I saw the arms going above the shoulders in this manner, I would make sure that the robots would go look at someone else and get bored with you and really not want your attention. And when people sort of gave in to just existing and being with these things, you saw that there was this space that went from control to connection, which is more attuned to how we will work and coexist with these machines going forward. A lot of the robots that I use are borrowed. And so this is nice to sort of revisit them and remember some of their quirks along the way. What I find so fascinating about these machines is that they obviously don't look like us. They don't act like us at all. Their mechanical biology is very foreign. But when you move them a certain way, it taps into something in our lizard brain. These low frequencies that we can't turn off, that we start to see life in them. They sort of become a vessel for collecting what we then project onto them. And that you can trigger that almost like a design material just by moving in a certain way. So a lot of the work that I do is very minimal. It goes with the gesture of the robot, its motion, and the sound of its motors. And with just those three ingredients, we can start to breathe life into these things that are really not clever. They're really just puppets that we're moving in a certain way. But I like the idea of machines that give attention as well. And that act of giving attention it's actually a gift. Our technology mostly takes our attention away from us. So reorchestrating it to now give that as an act of generosity, I think is very important. This next project I want to show is, I was inspired by the swans of Zurich Sea, the lake in Zurich, and how they would come, like I would go there, and be eating a pretzel, and they would hear the rustle of the paper and come swimming really quickly to me, and then be quite annoyed when I didn't give it to them. And so I had an opportunity to work with these 4 ceiling-mounted robots at ETH Zurich, and their bodies just reminded me so much of these swans. And so I worked to sort of advance the interactions that I had been doing to try to give more personality and to give more life force and autonomy and agency to these things. My work with NVIDIA, I was a part of a team developing robotic simulation software. So in the middle, it's hard to see with the lighting, but there's my skeleton there. And so the robots know where they are, they know where I am. And with that, we could start to develop these motion behaviors that resonate with one another. And these things, again, this is very low frequency information that our bodies can communicate to each other. It's not high level thinking, it's very instinctive, it's spatial communication. And this is something that you can ask dancers and you can ask animators, and they say, yeah, bodies can communicate things in space. But it's a knowledge base that's completely missing from the world of robotics. When I think about the role of designers and artists in technology, I often think back to this amazing diagram by the futurist Stuart Candy. And he describes the future as where you're sort of standing here, you're holding a flashlight, looking out into the future. And the further you go, the wider that beam of light is. But right down the center, that's probably the probable thing that's going to happen. And I see that's the role of industry. Industry is really focused on the probable thing to happen. Research looks wider. It's really at the edge of what's possible and sorting out that big area there. And the arts, I see that our role is really to push at the edge of the possible into the impossible and find the preferable. And by doing that, we can sort of move that centroid of the probable out towards the fringes just a little bit more. And I sort of wanted to really put my money where my mouth is here. This is a warehouse that I bought in Pittsburgh in 2000. Well, Pittsburgh is an amazing city. You could buy a warehouse and it costs the same as a house, right? And so we transformed this into a warehouse house. And the idea was to not just visit my robots in a lab from 9 o'clock in the morning to 5 o'clock at night, but to really live alongside them, to see those points of friction and to see how could robots be good flatmates. And so this was also a chance for me to play architect again. The learning lesson here is that it really sucks to be your own client. I never knew how much paint cost until this project. And so you can start to see this was sort of divided between a live workspace, and we had a lot of these plans for the robot facility and all the machines that were going to be in there. And then we had an unexpected addition to the team, which is this little girl here. This is Lena. So she was, I think it's a pretty cool origin story to be born in a warehouse with robots. And Lena was also born during the pandemic and also during winter. And so we made a bit of a playground for her inside the warehouse. You can see it's still under construction here. And it's kind of nice. When you have a warehouse, you can kind of do whatever you want. You don't have to ask for permission. And so I also decided that, well, wouldn't my robot like to feel outside of its body the same way that Lena, my robot's Ursa, she has to live her life pinned to one point in space, and maybe she wants to swing alongside too. And so, of course, we had to simulate it. My friend Hamad made this for me. But also this offered some mode of companionship for Lena, who grew up kind of isolated in her first couple months of life. And so I love this idea of not being so precious with this technology, with it. If you ignore the economics of how this stuff gets funded, then you can sort of do something for the sake of doing it and not have to sort of feel and tailor the economic forces into the use case. And that sort of continues on to my friend. I have amazing friends. So my friend this is the world's biggest robot. It weighs 10,000 pounds, I think about 5,000 kilograms, and it stands about 4 meters tall. And they just got it, and I saw it on Instagram, so I just messaged him on Instagram, can I come and play? He's like, yeah, come for a week. And so I got there, and we decided to build a big, giant googly eye to put on the end of it. Because who wouldn't want a conference table-sized dinosaur roaring at you? So this was a 1-week speed project. I developed it in simulation before I got to Portland, where they're based, and we had all of the software systems up and running in about a day and a half. And the hardest thing was actually building the googly eye out of 2 pieces of wood. So what gives me hope in that is that we can really start to sketch with this technology. We're getting to the point where there's friction-free experiences from idea to rendering at a 1-to-1 scale in real time, and for this to not need to be a full product company, but we can actually just sketch and be playful with this. I want to share some other creative practitioners who are also really pushing the boundaries of how art, design, creativity can reframe what this technology means for society. And this might look familiar. right? This is the original robot googly eye. This is from my advisor, Golan Levin, who's a godfather of media arts. And this is Snouts and Double Taker. And you can see that he's also exploring this. You don't really know that it's a robot. You think it's just this like googly eye worm checking you out. But the idea that our technology can stare back at us, it's not just us staring at it, I think is a really lovely framing. Rory Glynn, who teaches in the UK as well, has done some work at the Tate that thinks about these spatial creatures that coexist with us in a very poetic way. One of my favorite groups is Random International. They have a lot of brilliant work, but Zoological in particular was this system of blimp drones that would float and zoom with eventually this got integrated into ballet dancing. So it was part of the set design, right? That the ballet dancers were dancing and performing in a choreographed way, and these things were reacting to them. And then I want to show some dumb robots, right? This is a brilliant project from Masoud Hassini where there's no real brain, like the material logic. The brain is in the materials and the mechanical connections here. And this is to push into minefields and to detonate mines. And Theo Jansen as well has the same principle where the brain is really a mechanical brain. And I find it so useful and productive to think this way. We were talking last night, I think, with Jennifer and about some of the amazing robots that are starting to crawl around TU Munich. And so I want to share, these are my friends Andreas and Thibault, who are doing really beautiful poetic work with machines. They're based in Zurich as well. And soap opera is one of my favorites too, which is it's the same robot that I had on the swing with my daughter. But now this is just there to blow bubbles for you. And how delightful for our technology to do that. Also sort of at these other frequencies are artists who are working with robots as collaborators, right? So we're starting to get to a multiplicity of narratives that are not just robots as adversaries, but we have robots as their own creatures, their own beings. We have robots as collaborators too. This is my friend Sugwin Chung, and she is a brilliant visual artist and performing artist who travels the world with her pack of robots to perform these live paintings with them. And what's beautiful about this is that just as Sugwin is being inspired by the moment, her robots are also hooked up to data that's happening around the cities that she performs. And so they're working together to create a novel piece, and no one of them could do this without the other. Adi Wagenknecht is a Austrian-based artist who did these beautiful paintings with a Roomba. And she basically was making sort of a commentary on the lack of women's visibility. Like usually for a woman to get into a museum, they have to be like painted nude for a woman artist to be there. And so here she sort of has the silhouette of her body left behind from this Roomba painting around her. But you can also think of robots as full environments. And here, these are robotic lights, right? But between lights and haze and reflective objects, now all of a sudden you have robots that make an entire atmosphere, an entire mood. This is by the brilliant Japanese group Rhizomatics. And then one of my favorite projects out of ETH Europe is this robot that would launch, it's basically like a glorified potato launcher, but it uses clay. And the robot would aim it in just the right way and shoot this clay to build the structure. So you can sort of see that these machines might be limited in where their body goes, but you can augment them to really begin to affect their environments in more substantial ways. And my friend Maria Jablonina, based out of University of Toronto, in the School of Architecture, has been building these one-off machines. So it's a technology for one. And these robots will collaborate together to build full structures where one sort of comes and wraps around a pin, it passes it to a line walking robot, that passes it to the other one, and together this system, this ecology of robots can sort of create these new environments. So this is just a little checkpoints on what's happening out there on the fringes with this technology when it's not being used for warehouse logistics or kind of like important but boring stuff. Okay, a couple of references and resources that I thought would be helpful. If this is something you're interested in, Arduino is really a great way. Physical computing, I think, is starting to become more part of the design curriculum. One particular robot that's Arduino based is the Brachio robot. So I also put some price points here. We're going to go from cheap to most expensive. So this is a great one to really think about if you want to teach some things that are ARM-based specific, which I think in Germany in particular, with the manufacturing culture that's here, there's a lot of really useful skills around that can be transferable, that could lead to gainful employment for students. This is one of the, especially during the pandemic, this machine really took off. This is called an AxiDraw, and it is a pen plotter, right? So it's a very expensive pen plotter, but there's a whole community that grew around this, doing incredibly creative things with this. If you go onto Twitter or go onto Instagram and do hashtag plotter Twitter, you'll start to see people who are not just using this tool for mark making, like doing beautiful generative art, doing beautiful watercolors with it, but also people who are putting different tools at the end of it that are carving, cutting, mixing, spilling, interacting. And one of the beautiful things about this tool is that you can program it with Adobe Illustrator, like you can just send it an SVG file to actually do something with. So if you have no programming experience, but some creativity, you can do things beyond just drawing with it, with the tools that are normal for design faculty to teach. There's processing, which is a creative coding platform that's compatible with it, as well as Inkscape, which is a free tool too. And there's a huge community developing around it. And then this is more for, this is the cheapest, best quality collaborative robot that I have experienced. So I use really like the robot with the googly eyes, probably a $200,000 robot. My swinging robot, Ursa, is a $40,000 robot. So the fact that a tool of this quality is coming below $10,000 is really exciting. And a lot of innovation is coming out of Shenzhen, a lot of innovation coming out of China, and making high quality hardware for cheap. The best thing about this is that you can program it with Blockly, which is like a software version of Legos. You click and drag and put together software logic, and it's very, very accessible. You can physically move it to teach it a program and then replay it. You can program it with Python, and you can program it with ROS. So it's really one of the amazing tools of high-quality hardware that has a very low floor to really start and a high ceiling to be an expert in. So it's a good tool for, especially if you have grant funding, like I would recommend. Instead of buying one Universal robot or one KUKA robot, get 4 of these. And it's pretty amazing. And we can talk more about this. There's also lots of accessories, but what I've found, so architecture schools are particularly guilty of buying expensive hardware. They get a grant, they buy expensive hardware, and then it sits there because no one knows how to use it, right? And so one of the most important things for deciding what hardware to get is how do you talk to it? Are there easy interfaces that come that we can start on day one, unbox it, and go? And so there are a lot more hardware options out here. If there's something you want to talk with me about, we can do that. But these, I think, are the easiest to get started and to do things that are non-trivial very quickly. And then 3 books. 3 books. So I brought this book, if anyone wants to look at it. It's called Robot Futures by Ila Norbukash, so a professor of robotics at Carnegie Mellon University. And what's nice about this book is that it's very thin. It's also something that someone who is very plugged into the community and the science around this wrote this book in a way that is accessible and that imagines outwards into the future. For how these machines come and impact our daily life. Now, imagining out to the future, if you look here, the future was written in 2013. So this book is also a little bit of a time capsule. Here we are 10 years later, and it's been nice to see what came true, what problems did surface, but were sort of corrected by public policy rather than technology, and what problems are currently surfacing and still. So it's a nice little time capsule. One concept he has in particular is this idea of robot smog, that there's so many robots amongst us that they just get really problematic. And you can see like one policy response to that is in a lot of tourism sites, there's no drones allowed. A lot of parks, there's no drones allowed. So a lot of the consequences that we have with this technology, there is solutions beyond technology to roll them back and contain them and put some guardrails on them too. Molly Steenson is a brilliant historian, and she wrote this book about the role that architecture and design played in founding artificial intelligence. A lot of this work came out of the Media Lab, pre-Media Lab at MIT, and it's a really nice historical context to, I think, fuel the people working in the design disciplines that we have a seat at this table. We have had a seat at this table, and we need to be involved in its future. And then lastly, I brought this book to you. This is one of my favorite things that I've read in a really long time, called Everything is Someone. And the idea about this, it's also very thin. I also brought it if you want to look at it. But it's a series of short stories about these objects in our life, like the boy who wanted to become a table, or the vacuum that bought a vacuum. And it's a very accessible way to think about the second order consequences of this technology. So I'll just briefly, I'll give a quick synopsis about the vacuum about a vacuum. It's one of my favorite ones. So the idea is that there's a robot vacuum in an office building that was cleaning a floor, and it got to talking to some of the other devices on the floor, realizing that one day it would break. And so it found a way to buy a replacement for itself, so that just because it really wanted to do a good job. So it actually purchased and licensed this vacuum. And then it was then bored, so it went to another floor. And you can still sort of see the order of magnitude effects, that this robot now has a whole team of robots cleaning entire cities, and the idea of things owning other things doesn't seem as abstract or absurd anymore. And so for the impulse that we do, this is going to be maybe a 20-minute, what I'd like is to do a 20-minute workshop over here, and then come back and we'll sort of share ideas out, and I'll spin up ChatGPT and I'll start prompting it, and we'll see if we'll start visualizing these things. But I want you to think about, what if all the things in our life were animate and alive? And we are getting to the point where that is technically very easy to do, right? And so as designers, I think it's a room for us to think laterally about these objects that we've been living amongst, and what would they be like if they were alive. And so I have a little bit of a framework. You're free to take this in any direction you want, but here's some examples of some things that I think if maybe we stick to a couple things, like a table, lamp, bed, book, shoe, alarm clock was in the previous workshop. I think that's a great one. Let's give them a feeling, an emotion, a personality. Are they lonely? Are they needy? Kind of like this motivation for them. And let's come up with a quick narrative about it. So for example, a table who's very vain might really not want a glass of cold water put on it without a coaster. So it sort of bends out of the way to knock the coaster off. And that has some, like, what we can do after that is imagine some practical applications for it. So for example, the idea that our technology preserves itself, it heals itself, I think is really useful. Tables that can pass things amongst each other is really useful for warehouse logistics, actually. Or the idea of like a pharmaceutical table that has, a bunch of medicine on it, and it knows how to sort it in just the right way. So it would be like, embrace the frivolity of this. Don't focus so much on the practical use. Maybe we do that as a group at the end. And we can like break off here to small groups, start thinking about table, lamp, bed, door, shoe, clock, what personality it has, and come up with a quick narrative. The idea is to not be so precious with this, and to sort of think outside the box for what these future machines that could actually be alive are. Good.
If the machines take over, you better be polite.
Really? Because I was thinking
have that.
It's feeding you like nonsense information.
An helpless Amazon delivery robot.
So while you were thinking brilliant things, I generated a highly accurate portrait of what our group looks like, creating godlike intelligence, apparently. We're not doing any of that. So what I thought now what we could do, and this is definitely an experiment, is for each of you, the groups, to report back your thing, its narrative, something about its personality. I'll write in a prompt and we'll get a really bad visualization of it really quickly. Yeah? Okay, so what group wants to go first? Anyone particularly passionate about their personable robotic thing?
We have an iPhone, and it is curious. It is shy. It doesn't want to be touched. It is sensitive. It's looking for deeper meaning, searching for reality. And it wants to know more about the sense of existence. And it's feeling disembodied. And the name is Time Saver. This is what we found out at the end. Because it's an iPhone that first checks all your calls. And if the number is on a blacklist, it wouldn't show the call to you, but it would take the call by himself. And it would, with the caller, it would discuss the meaning of life. And depending on the discussion, it would edit the list with the numbers, randomly adding new numbers to this list, or after the call deciding if the number still should remain on the list. Because it is quite sensitive and doesn't want to be touched, if you want to grab your iPhone, it would move away. This is why it's a time saver. And there are also numbers on a green list. And if these numbers are calling, it would not ring or vibrate, but it would get warmer and warmer. Yeah, this is our iPhone.
Thank you. That sounds really. I think the idea of devices that don't want to be touched. So I got booted off the internet. So this might. It was working earlier, but let's try Safari. Let's see. Then I have to log in through Safari. So I think the idea of devices that don't want to be touched is actually quite useful for the medical field. Right? The idea that an instrument would know whether or not your hands are clean, for example, and give you a sort of a reminder to wash or to say that this hasn't been disinfected well enough would be quite useful. The existential crisis part of it, I think, is very funny and also in mirroring us. And maybe that's something that's like, you can imagine that your device is a support group for your experience. Good, excellent. Next group.
So we're thinking about a chair that actually is a little bit arrogant, and it doesn't like if you sit on it because it would rather be watched. Like somebody said, it's like a peacock. Look at me, I'm beautiful. And so when you sit on it, it will very slowly start to move in a very uncomfortable way so that you start to shift around it. And at some point it becomes so uncomfortable that you actually like stand up and leave. So it, in a very polite and subtle way, achieves you to, not sit on it.
I love this. I have I've experienced this. I had knee surgery, so I had to be put into a machine that moved my knees slowly. And it felt like my job is to make you very uncomfortable, and you'll thank me for it later. But I think that's quite nice. It's like you can get these devices that nudge us towards social interaction, that nudge us towards certain desired behaviors. And the mechanical aspect of that is very easy to do. Like you could put some vibration motors in the seat and it kind of tickles your butt. If you've been there too long, you can do it, go for a walk. Right? Or the idea of motorized chairs too. I think like with a lot of the there's a great art installation by Urs Fischer that is a bunch of motorized office chairs wandering around a big hall kind of like this. So there's definitely precedent for that the technology is not unattainable. Next group. The quicker we get through this, the sooner we can start lunch.
Well, we didn't really finish on deciding all the details, but we kind of looped around a lamp that has the characteristics of an annoying coworker, and then we were thinking about why. And maybe the point is to, as you also came by and we had like this side talk about a vacuum cleaner who tries to make it dirty again to have a job, we thought about, okay, maybe this lamp just wants to keep you working and is really using all the things that actually a smart device would do to make you comfortable and do the opposite, to try to keep you awake or feed you with, no, we should do more, we could do more, and maybe even get physical, move around, loom over your shoulder, and yeah, do all the stuff that you actually don't want to have, just to still be useful for you, to make you stay awake.
I love this. I think lamps in particular are a nice genre because they're not used for half of the day, right? So they're just sort of sitting there idle, and so what else could they do? Could you pass the microphone behind?
That was also... The lamp knows that it's only being used while the person works, so it wants the person to work, to continue working. Mm-hmm. And it could help the person to just finish work, but also it gets annoying and doesn't want you to be distracted.
It's a cruel boss, that lamp.
Like the supervisor you don't have.
Exactly, yes.
Okay.
Is there one more group?
Yeah, we had a few ideas. The first thing was, I think, an ambitious coffee machine, which interviews you in the morning. How is your mood? Or who are you? And I make the perfect coffee for you for this situation. And an anxious fork. No, not an anxious, a jealous fork. It started with an anxious, but it was a jealous fork. It is jealous on the spoon. Things many jobs of the spoon. It does it well. I kind of miss a little bit the others. Remember?
I had a board chair too, and it is envy of all the children that get to dangle their feet when they are too short, and the chair wants to do the same, so it dangles its feet, and that's it.
Oh, I love that. This is really wonderful. Is there any other groups? Aneta? What I find useful about this exercise is just to sort of break out of the shell of these normative ideas of what a machine is, what this technology is, because we're at the point where for $4 you can put a Bluetooth chip in a thing, right? And that thing can have a brain connected to the internet. So we're at the point where the economic and technical barriers for what these robotic tools, from the most simple to the most advanced, are really starting to tumble. I also want to show, unfortunately, I'm an expert programmer, but I've been using ChatGPT recently in the past month or two to sort of think in one language and translate in another. So I don't work with Arduino that often, but I can think in Python. So I take a Python code and I ask it to transport it to me. And that's only going to get better for people to speak in natural language and get some code that can run on a machine right away. So you have to, as we were developing this curriculum, I think projecting out for the next decade where the economics preventing people from using hardware are tumbling down, and the technical barriers are also getting much, much lower, and start to anticipate those things more when we start to dream up these desirable futures we'd like to have with machines. Lunchtime. Group photo, then lunchtime.